trials. Basically because the models that we have, especially in toxicology, the toxicology models we have really rely heavily upon rodents and sometimes they have to use monkeys, but they really don't reflect the human situation, human biology. So this might actually, instead of speeding up drug development, it will be able to weed out some of the drugs that we're developing that will fail.
And they will fail on two counts. One is safety, namely the toxicity that they cause is higher than permitted. So the safety component is phase 1, and the efficacy is phase 2. The new drug under clinical trial provide outcomes that are better than the existing drug on the market.
Well, that makes sense. So, and I know when I've worked with pharma companies, I know that even they admit, okay, so you've got this brand new drug for diabetes, let's pretend. You've done the trials, they go on for quite a long time. They don't just go on the market 3 days after you've tested them. So they're very careful, but they've said to me, the first year, maybe even 2, that it's in a whole much wider population. Who knows what will pop up? Whereas it sounds like if you're doing it really on human genetics and not on monkeys and rats and pigs and so forth, they're more likely to get there, be stable, and be good for people, right?
That is an important aspect of it for drug discovery as well as in medical devices. It enables to simulate the reality in as close as possible to the real organ or the real device and the interaction between the organ and the device.
So if my husband had this 20-something years ago when he lost a left knee during his military service and they didn't have the minimally invasive procedures that they finally developed, so you people would have been able to create a new left knee for him and put it in? Would that have worked?
Yes.
Wow.
Nowadays they do.
So we're actually using this now.
Yes, they do synthetic as well as bioprinting of implants, of knee implants.
For example, for hip replacement, they produce the inside the femur. They need to put a device, and it is printed by 3D printing.
Huh. So it fits nicely into your hip socket, and so this would work well, especially here on Partners in Health and Biz. We focus very much on an aging population and our senior boomer market. It used to be they wouldn't even do a hip replacement once you were past, let's say, 65 or 70, and now we're doing it in people in their 80s, and it sounds like it would be far more compatible and less dangerous for them.
Correct.
One thing that why is bioprinting so popular, just to give you an idea, like in U.S., every 10 minutes you have people on transplant waiting list. So there's about 20 people die each day waiting for a transplant. So when you're thinking just in U.S. alone, there's 120,000 people waiting for a transplant.
Wow.
And you can imagine why bioprinting is so popular. So instead of waiting for that organ, if we can use the patient's cells to actually be able to to decrease the amount of immunosuppressant drug, to decrease the time of getting that organ. So there are people already dying waiting for an organ.
Now, but you said things like the heart and the kidneys, I think it was the kidneys, they're very complex. So are we getting this done already in those organs? And what do the doctors and the other health pros know to get a patient to a facility that can do this kind of work?
Like Dr. Williams mentioned, Organovos actually with liver. But they're working into heart transplant too. So there are companies that are trying. The problem is getting them working properly before using clinical use.
Yeah, and the field is at the stage where there's been done a lot of experimental work. Well, in animals, when we graft these into animals, we have to sort of scale up to the size of a human, first of all. And second of all, we really have to work on both keeping these tissues healthy and viable over a much longer time than we have been able to, and also to actually improve some of the functionality of these tissues. So I'll give you an example. One actually that we have in the book, which is very exciting. People have been able to reconstruct and 3D print an ovary. This was, I believe, done in rat, but it was fully functional. The rats that were implanted with these bioprinted ovaries, they were able to actually produce viable offspring, get pregnant and have babies, and they were all fine. If we can actually get that up to the level of both the complexity and the size of a human ovary, it's going to sort of revolutionize what we can do in oncology, where a lot of times a woman will come in and be in a high-risk situation or from a family background that is high risk for ovarian cancer. She may have a BRCA1, 2 mutation or just a family history. We can actually then hopefully bioprint her a new functional ovary that has all those defects correct, either from her own cells, where we use another technology like CRISPR to actually correct those certain genes, or possibly use her own stem cells to recreate some of the cells in that tissue. In that case, then a woman wouldn't mind going in and having a bilateral prophylactic ovarectomy, because she would know that she could actually get new ovaries that were completely healthy and be able to have kids. So the future is very bright. It's just that in sort of scale, we have to get there. Most of the work has been done with this replacing structural features. Right. So as much as like a mandible, jaw, an ear, certain joints have been done. But the more complex situations, the pancreas or the kidney, it's just probably going to be in the near future that we're going to be able to do this at the clinical level.
Let me ask you this. When you mention ovarian cancer, that's very interesting. It's nice to be able to talk about it as a preventive measure if you already know it runs in the family. But what if, as you know, very often women aren't diagnosed until it's very late already? Could we take out the contaminated ovary, the cancerous ovary, and maybe she can't provide the cells, but maybe she's got a close relative that...
You mentioned the difficulty. The difficulty is that we usually detect ovarian cancer where it's called in stage 3 or stage 4.
Yeah.
That's when it's really, the ovary is pretty much full with cancer cells. At the earliest stages, you can detect it there. We can cure it very easily.
Would you be able to pull cells from a relative, perhaps?
It possibly could be, because now we can do some certain genetic manipulations that can actually, Zarina said, the problem is about, in that case, it would be basically a transplant from another patient. So you would have problems, complications of the immune complications as well.
Right. On the same note, I don't know if you're aware, but in 2011 in Belgium, using 3D bioprinting, they did a full face transplant. So they used 3D bioprinting to basically a person that has a facial deformity to restore the bone structure.
Well, I know the work of the Phoenix Society, which in this country and maybe even beyond helps people with burn issues. So perhaps it's something you could help someone who's had part of a face or a hand or something like that really corrupted, and you could put it back?
Correct, and one can create also biobanks of artificial tissues.
Wow.
There are researchers at the University of Sydney, MIT, Harvard, and Stanford that successfully developed bioprinted blood vessels, offering 3D printed organ access to nutrient, oxygen, and waste disposal routes, according to a study that was published recently. So while recreating little parts of tissues in the lab is something that we have already been able to do, the possibility of printing three-dimensional tissues with functional blood capillaries in the blink of an eye is a game changer.
Yeah.
On the same note that Dr. Williams said with tissue complex organs, even though we can't actually recreate 3D bioprinting organs fully now, but we can create still pieces of it. For example, we can still create valves, or we can create an aorta that goes into the heart, or pieces of the heart muscle. So there are pieces that we can recreate, even though there's still the complexity of the organ itself.
Well, you won't believe this, folks, but it's actually time to be winding down, and I'm glad we put it on such a positive note of what we can do so far. I mean, it's absolutely amazing when you talk about 3D bioprinting, and I'm going to thank all of my guests who have been part of the book called Medical 3D Bioprinting, The Revolution in Medicine. I'm going to tell everybody your names one more time, and then if one of you can tell me the best way to get the book. So my three amazing PhD this week have been Drs. Aviva Lev-Ari, Dr. Irina Robu, and Dr. Stephen J. Williams, and they're all PhD doctors. So one of you tell me, how do people get the book? Because I saw it on Amazon.com. Is that the best way?
Yeah, on Amazon.com. They go to Kindle store, and they can type the name of each of us or the name of the book, and they can get it.
Okay, so let me just tell them it's easy as go to Amazon.com, type in Medical 3D Bioprinting, and you'll get there right away.
Okay. The entire title, please, because there are other books on 3D bioprinting. Entire title of the book, which is Medical 3D Bioprinting: The Revolution in Medicine. This is a unique title to our book.
Okay.
And please go to our site at pharmaceuticalintelligence.com because we constantly put up the latest update on what's happening in this field as well as other fields as well related to biomedicine and science.
And I'll put it on our LinkedIn page and all the other stuff. I'll give them the URLs, so that'll make it easy for folks to both find the recording that we're doing right now and to get the book. So
excellent.
I want to thank you all again. I've got to remind folks to tune in next week at 9 a.m. That's when my partner Gail Dixon offers her next wellness topic. And of course, as I just mentioned, we put it on LinkedIn, Facebook, Twitter. We repeat the episode on Spreaker.com about 3 or 4 days after you hear it on Blog Talk Radio. And I want to remind people, if you have any questions, if you need clarifications, and I can get it to these fine people, you can contact me also about advertising or being a guest at wendyjm.pih@gmail.com. It's wendyjm.pih@gmail.com. You can find us on Spreaker for the Partners in Health and Biz. So look me up at WMMedcom, COMM.com. You'll see my contact info there. You can call me. So again, I thank our guests. This is Wendy Myeroff, and this has been a great episode of Partners in Health and Biz. Enjoy your weekend, everybody.